Hey everyone. Today, we're going to pull back the curtain on one of JavaScript's most, let's say, interesting features. Its secret ability to change the identity of your data on the fly. It's this hidden set of rules that can feel like magic one minute and a massive bug the next. Okay, you ready? Let's dive in. So let's kick things off with a little puzzle. We all know computers are logical, right? Numbers are for math and text is for, reading. So how on earth can a computer do math with text? Take a look at this. We are literally asking the computer to divide the piece of text 6 by the piece of text 2. Your brain is probably telling you, no way, that should throw an error. That's impossible. But in JavaScript, it just works. You get the number 3. This is the mystery we're going to unravel today. To really get what's happening here, we first need to talk about a concept I like to call a digital identity crisis. See, every single piece of data in a computer has a specific identity, and the computer has to know what that identity is before it can do anything at all. That identity has a formal name. It's called a data type. Think of it like a label that tells the computer, hey, this is a number, so you can do math with it. Or, watch out, this is text, so you can only display it on a screen. It's the fundamental rulebook for how data can be used. Now, what's so wild about this is how a tiny little detail can change everything. See those quotation marks? The number 1, 2, 3 is a value, something you can add or subtract. But 1, 2, 3 in quotes, that's just text. It's like the difference between an actual hammer and a picture of a hammer. They look similar, but you definitely can't build a house with the picture. Okay, so sometimes to avoid just crashing, JavaScript will force different data types to, well, speak the same language. And the most common language it defaults to is text, or what programmers call strings. This process is called string conversion, and honestly, it's the most straightforward one. If you need to show something on the screen, JavaScript just turns it into text. The logical value true becomes the word true, the number 100 becomes the text 100. Makes sense, right? Pretty intuitive. But things get way more interesting when JavaScript decides it needs a number. And this brings us right back to our original puzzle. To do math, everything has to be a number. JavaScript has some very specific rules for making that happen. This table right here, this is our secret decoder ring. When JavaScript needs to turn something into a number, these are the exact rules it follows, every single time. As you can see, true becomes 1, false becomes 0, and null, which basically means nothing, becomes 0 as well. When it sees a string, it trims off any extra spaces and then tries to read it as a number. So here it is, the big reveal. When JavaScript sees that division sign, it knows, okay, time to do math. So it looks at the text 6 and, following its own rules, converts it to the number 6. It does the same thing for the text 2, turning it into the number 2. And boom, the impossible problem is suddenly just simple math. Mystery solved. Let's just zoom in on one of those rules for a second, because it's pretty interesting. The value null, which is what programmers use to say this intentionally has no value, gets converted into the number 0 whenever math is involved. But, and this is a really important but, if a value is undefined, meaning no one ever gave it a value in the first place, it doesn't become 0. Instead, it becomes NaN, which stands for not a number. It's basically JavaScript's way of throwing its hands up and saying, hey, I tried to make a number, but there was literally nothing here to begin with. All right, on to our last type of conversion, Boolean. This is all about one simple question. Is something true or is it false? The rules seem really straightforward, but of course, there's one massive surprise waiting for us. The general rule is actually pretty simple. Anything that is considered empty or nothing is treated as false. That list includes the number 0, an empty text string, null, undefined, and even our old friend NaN. Anything else in the entire language is considered true. Okay, this seems easy enough. An empty string is false. Got it. But what about a string that isn't empty but just has a 0 inside of it? You'd think that would be false too, right? I mean, it's a 0. Well, you would be wrong, and this is where things get genuinely weird. The official rule in JavaScript is that any string that is not completely empty is considered true. It doesn't matter what's inside it. That's right, because the string 0 contains a character, the 0 character. It's not technically empty, so JavaScript says it's true. And get this, even a string that only has a blank space in it is also considered true. This is a classic gotcha that trips up even experienced developers. So let's wrap all this up by going over the biggest, most common quirks we've talked about. If you can just commit these few things to memory, you'll have a much, much better handle on how JavaScript is thinking under the hood. Okay, here are the three big takeaways. Number one, undefined turns into not a number, not zero. That's a huge one. Number two, the string with a zero in it is true because it's not empty. And number three, for the exact same reason, a string with just a space in it is also true. Remember those three and you'll save yourself a lot of headaches. When we see how a few hidden rules can make a programming language behave in such unexpected ways, it really makes you wonder, doesn't it? What other invisible logic is quietly running in the background, shaping the software we use every single day? Something to think about. Thanks so much for joining me.